Okay. Okay. Hello, everyone. It's a great pleasure to be all of us here together, and I would like to introduce someone that you don't know at all. Paolo Bonfini did his PhD here with Andrea some time ago, and actually he had come even earlier as a Erasmus student. And he came to Crete. He liked Crete so much that even though he had an offer to go to Oxford for a PhD, he decided to come here and do his PhD here. Now, if it were Cambridge, it would have been different, of course, but as we know,
You see Cambridge, you see Oxford.
Exactly. So anyway, so Paolo worked with Andreas, and then he did a couple of postdocs, one in Australia, down under, and then he went to Mexico, and then he decided that Greece and Crete is a great place to be. So he came here and he worked a bit with us, Andreas and myself, and then he decided, since he was doing a lot of data analysis for his papers, to do a more sophisticated data analysis and machine learning techniques. So he progressively worked with some people in the computer science department and then in the private sector. And he will tell us today about his experiences on this endeavor. Thank you very much, Paolo.
Thank you. So what I wanted to show you is, okay, I'll give you a brief recap of what I've done in my life. I mean, starting from the PhD. And then I want to show you what type of projects you could do if you switch to the evil side, corporate environment. And then I'll give some advices about what you could try to do if you want to do the job and which sort of expertise are required in that case. And then I will complete this with a small presentation of a demo of something we are working right now in our company that I want to show to Andreas, which I don't see here today, or Vassos and Kostas.
They all have jobs
here. They have jobs outside academia. Okay. Well, we will talk about this for a collaboration eventually. Anyways, so let's get started. So this quick recap of my career. I got a PhD in Astrophysics 2013, and then I did some postdocs at the Swinbu University, at UNAM, National University of Mexico. And when I came back here, some short postdocs with the Observatory of Athens and Forth. Then I decided that astrophysics was too easy. So I switched to bioinformatics, and actually I went smoothly into this because I did a postdoc at the CSD department here. Yeah. And this was like about 1 year and a half. And then I was approached by a company which was offering 3 times the salary I was having in academia. And I said, why not? Let's give it a try. I will cry, with the meme, with the money. And this was a company from US. I was working remotely. And so I stayed 1 year and a half as well with this ballista technology group. And then eventually I landed in the company I'm working now. I'll give you more details in a second for the things you see, which is Alma Sistemi. This is based in Italy. It's an aerospace company. So for the astrophysics, I specialize mostly in galaxy morphology and especially in light profiles fitting. As you can see here, these are examples of this. This is my laptop, or it's probably the mobile. It's the mobile. I told my mother not to call me right now. Yes, I have to rush it. So, real quick. So, in this case, this is an example of a fitting of a core galaxy. This is the center of a galaxy, where I use the radiative transfer to fit the inner circle of dust over here and to the galaxy morphology for the rest. So, it's a combination of techniques. So, it's like a kind of a Monte Carlo simulation where you combine 2D light fitting and radiative transfer at once. to determine the properties of the galaxy and the inner disk at the same time. So this is what 2D fitting looks like. You have some image and you have a 2D model. These are the residuals. And then in general, throughout these different projects I carried out, I try to link the morphology to galaxy evolution. So in this paper from 15, I think, I was trying to connect the fine structure, which is the intensity of the disturbance of the galaxy morphology, which is related to the fact that the galaxies, they come from mergers, of course, so more recent interaction caused more disturbance, and this disturbance slowly fades out because the morphology of the galaxy relaxes. So at the other edge, you have galaxies that are perfectly relaxed, and I'm talking about massive elliptical galaxies, of course, not spiral galaxies. And the correlation was with the amount of mass depleted by the binary black hole that form at the center because of the interaction, right? Because you have a merger, you have two supermassive black hole spiraling in, and they kick out stars, like this process that we studied in Astrophysics 2 or something, you know. So yeah, I highlighted this connection between two processes that they happen at the same time during the formation of the galaxy in the next giga-year or so. So you have a core being depleted, and at the same time, the morphology relaxes. I also worked on a lot more topics in my career, AGNs, XRBs, globular clusters, blah, blah, blah. So long story short, this was a mistake, okay? If you want to have a career in astrophysics, you have to, and I'll be very straight, milk the cow. One topic, and you keep publishing like a printer on that one. If you change topic, you're never recognized as an expert in that. I've never been invited in a conference as invited speaker because despite I was basically at the state of the art or beyond, nobody knows your name. It's all about PRs, right? So if you keep publishing on the same topic, eventually they know you, and this is how you get. So it's nice, it's interesting to do different stuff, but career-wise, it's a mistake, okay? So I tell this a posteriori, of course. All right, so in bioinformatics, I was working here at the UOC with Professor Tsamardinos, and the project was about finding an algorithm that can translate gene expression from mouse to human. I don't know if you're familiar with that, but gene expression is how much of a chunk of your DNA, the genes, get expressed, meaning is transformed into proteins, okay? For the coding genes, of course, we have 20,000 genes in the DNA, plus we have non-coding part of the DNA, but this is a long story. The idea is if you manage to do that, then you can do experiment on mice that are sacrificable, I would say, so far. And you can predict the outcome on humans, okay? So here I put a sketch, sorry if I rushed it a bit, but just to make you understand qualitatively what happens. So you have your data for a mouse with different genes, and you have the different values for the expression and different samples. And you may have some that are, they have a disease and some that are controlled. So you have this in n dimensions, like tens of thousands of dimensions, and you want to find a common embedding so that you can take the human data, bring this in the common embedding, okay? And then you want to try to guess which are the disease or control humans. And you can do this if you actually learn a classifier in the regional space, and then you learn the transformation from the common embedding. So you can actually apply this separation here because the humans that they follow the disease or control distribution, they will be distributed in the same spot. So eventually you can actually apply the classification also to the human. So you can understand the advantage of this technique, right? So the idea was from Professor Tsamardinos. I kind of implemented it and extended it. Actually, so much that I actually can transform images with the same technique. It's so generic, And I was looking for an image, but I deleted I don't have it in this hard drive, but I could translate from male to female images, like, having the image of a male and having the same person, let's say, transformed to female, whatever this means in 2024, and vice versa. And yes, assuming a binary distribution. I know it's a bit limit. This is the limit of the model so far. It works for 2 classes. Then, when I switched to companies, I was hired directly as senior data scientist, having done several postdocs, and I will come back to that later, which level you can enter in the companies. So I was directly hired as senior, and mostly I worked on development of techniques for DevOps optimization. I don't know if you're familiar with the terminology DevOps. Basically is the type of informatics techniques that brings a software into deployment, several platforms. Okay. One of these was optimize Apache Kafka. I don't know if you heard about this software, or if you've seen this logo. Kafka is a sort of streaming platform. Basically, it was invented by LinkedIn, and it's made in order to optimize the latency and throughput of a system. You have several producers and several consumers. Okay, it's a very corporate thing, even the terminology. So you have people like you can think of it as if it was Facebook. Okay, this doesn't assist the newest generations here. A bank system. Okay, you have people doing transaction. You have a system that has to process this transaction and report to the consumer, which is the other person having the bank account receiving money. Okay, so you have to make it such that these things happen very fast. Okay, for example, someone posts something on LinkedIn and it should be visible to everyone. So in order to do this, the system, they distribute these events so that they can process in parallel, and also they have redundancy by distributing copies over several servers on the same cluster. So the point is that these systems are very complex, and you need to, as a DevOps, you need to learn a lot of parameters to set this up correctly to maximize the throughput. And this depends on the necessity of your company, okay? Maybe you have a lot of data coming in, or maybe you have data coming very fast. You have a lot of producers, a lot of consumers, it depends. You have limited resources for setting up the cluster. So the idea is that the project was, and I completely led this and actually did it 95% by myself. It was about creating an ML system that could actually determine automatically which were the best parameters given some constraints that the company had. So it was actually a multi-objective constrained optimization problem, because you have to optimize for throughput and latency. So you have multi-objective throughput and latency, but also constrained by the few parameters that the user node they want to set. Okay. So again, these are setting up this. It means setting up thousands and thousands of parameters, and usually takes weeks to individual DevOps to set up. And with this, with the demo I had, it was just a matter of instant, right? Run the thing in a few seconds, you have all the parameters. To do this, I give you an idea of what you had I had to learn, because okay, the Bayesian optimization we all know from our studies as well. Machine learning, for those who studied, it's also kind of trivial, let's say, in a way, in the sense that it comes out naturally from your education. But these are strictly development tools. So Kafka, Docker, maybe somebody have used Docker. Maybe did you write a Docker container? No. Did anyone? No. Kubernetes. Kubernetes is something that can load containers like Docker, and it makes sure that if one fails, it loads up another one, for example, and keeps the synchronization. So it's a step on top of this. Okay. So actually, our Kafka was loaded on a Kubernetes cluster that contained Docker containers, and all of this system was uploaded on Amazon Cloud. Okay, so you can actually use it from outside. And this, on top of this, I had to run the simulation that was actually trying different parameters and switching on and off the system several times. So this is just to give you an idea of the type of job, which it is purely data analysis here. We had also another small job with our colleague that we have here, Tassos Litsas, who is now, you are as senior machine learning engineer in ALMA Sistemi, where I am currently leading research engineer. So now we're going towards a bit more something that I like more, which is not just work as data analyst, but actually design the whole procedure for the analysis of data. So top to bottom design projects, basically. Here we are doing a lot of things and I've been involved in a lot of different projects, mostly quantum machine learning, a lot of time series forecasting, a lot of computer vision platforms. For example, in this one, it's from a project where all the several types of informations are gathered to predict some development indices for grid. So in this case, we have a snapshot in a certain area. Well, the map is not really matching the image, but you can actually zoom in Crete, and there you have in the sea the automatic detection of the boats. And then by counting this and putting this in a time series, along with other predictors, like for example, the number of lights that are being used, electricity and so on, you can predict the development of a specific area in the island, for example. Of course, well, this is from another paper that we put. These are two different papers. This paper is from hybrid quantum computing, where we were testing 4 time series tasks, actually. This was for traffic control. We were trying to approach this, which was the classic machine learning approach, or hybrid, where we mixed fully connected layers with quantum layers in hybrid neural networks. And then, as you can understand, this comes with a lot of papers and proposals that we have to write on top of like collaborating with other companies. So we have it's very, very different. And despite the main companies in aerospace, we are actually in a separate sector, as you may have understood, which is like the research and development area. So this just to say that if you dig enough, you find these sort of things that you have to be aware, though they are mostly sponsored by European Union, because companies don't like to spend for money if there is no direct outcome. One thing I will show you later, just to give you an idea what we're actually doing, is this QML arena. So I leave it there for now. And instead, I want to give you some ideas and tricks about what you can find. So sorted by price, let's say. Well, developer, DevOps, data engineer, these are all keywords that you find in LinkedIn and whatnot. So I am explaining you what it means. So developer means programmer, okay? Basic salary, because there's a lot of people able to do that. DevOps, and now MLOps, it means to deploy software. And for example, you have pipeline of software doing a lot of stuff and you want to deploy it on the cloud services. This is a classic example, okay? These are extremely researched. There is a lot of demand for this and they pay very well, okay? So arguably the most boring job that you can find, but because you, as I said, for Kafka, you have to set up a lot of parameters, so you have to know that software very well. But if you know, you can have extreme salaries, okay? Like in US, for this type of job, you can get easily $10,000 per month. And now it's getting very fashionable with ML, because you can develop machine learning models. And one thing is to have it in your Jupyter notebook, but this is not a deployment. You cannot, a company doesn't, like, you cannot create a product with a Jupyter notebook, right? You have to package it in a way that works, is distributed, it has failure resilience and whatnot. So this is the MLOps. Data engineering mean essentially data preprocessing, okay? For example, you have to, you also hear it as feature engineering, You basically have to collect data, sort them, clean them, put them in a database. Okay, so you do everything before the analysis starts, and that's the data scientist, which is usually predictive analysis, and most of the time in time series, because that's where the big money are, which are insurance companies trying not to be SEO, and financial companies. Okay. And then there is ML engineer, maybe you can ask us maybe a few more questions, which is essentially assemble and create machine learning pipelines. If you know some machine learning, what is required here is not the machine learning that we do at scientific level. It is LLMs, large language models. Okay, if you use the APIs of ChatGPT, for example, did anyone try to use? Okay, don't raise the hand. No. Did you use, for example, transformers? Okay, so rule that out. And here is what you would need in order of marketing, let's say how much it's marketed your expertise there. In developing JavaScript and and TypeScript are arguably the most requested. I mean, this is a sort of ratio between the request and the salary you get, okay, in this vertical order. Then there is Java, which is basically dying off, but exactly because a lot of things is written in Java, they need people who know how to maintain the system, okay? So this is dying off as a language, but people is, by the way, JavaScript and Java, not the same thing. And then, unfortunately, last is Python, because there's just so much people who knows Python that, yeah, it's requested, but you cannot expect a big salary from that because the competition is basically any person coming out from a university. Now, if you want instead to go for the big money, DevOps, MLOps, you need to know cloud services like any service from Amazon or Azure. Have you ever used any? Azure is Microsoft, created by Microsoft. They have also their patents, so you can follow courses and, you know, pay how much, 150 euros, something like this. You give the exam and they give you something that lasts for 1 or 2 years, which is a bullet point you put in your CV to get the job. Flink for distributed system computation. I assume not. This we said no. Okay, if you want to go for data engineering, you must know database. So MySQL, which is not SQL, just Microsoft SQL. Okay, I'll stop asking. Or MongoDB. And for data analysis, for example, I just put one because it's so diverse. This Prophet is created from Meta and is a model for forecasting, which basically beats everything that we have so far. Forget about ARMA models, ARIMA models, you know, autoregressive, these things that you learn in time series 1, X plus beta X. Okay, this not really used. And if you want to go for ML engineering instead, okay, you need to get a little bit, I think something you can do. You can go one step beyond what you know and try to play with TensorFlow Extended, which is for deployment. This is PyTorch Lightning, which speeds up a lot of setup. And ONNX is for exporting, importing models. So this is what you could do coming out from astronomy and using your practical expertise. Of course, there are the soft expertise, which are, you know, managing projects, writing papers. These all things that are very variable because they need people that they are independent, essentially, okay? But I'll get back to that in a second. And this is one more thing that I found the other day. This is for 2023, I believe. This is the languages ranked on GitHub based on the usage. So they have their own database and they figure out how much is used. And as you can see, Python is the most used code. And that's what I meant before. Like there is a lot of competition. A lot of people know how to write Python. Okay, despite is the most famous. Yeah, nobody uses C anymore at all. At most C++ or C#. But what I mean is, when you see this sort of things, don't get fooled, because it's a balance between how many people use this and how much is requested by the company. So it's not one-to-one correlation with this. Well, this concludes the part where I give you the highlights, but I don't want the questions yet. I want to show you first the other platform. I want to say, so if the two questions that you may be thinking is, when is the best time to make this jump if you need to do it? And how much time I have to do this? So the worst is probably after your PhD, because PhD for companies equal student, not equal professional. If you want to be considered a professional, you must have at least one postdoc, because this is, even if it's 1 year, 6 months, doesn't matter. It's the label that matters, because this is, you're considered an independent person that can deal with a research group, okay? Even if the research group is yourself. Otherwise, right after the master. And I say this because this connects with the second part. By the way, regarding this, there are different levels. Like we have research associate professor. In a corporate, there is the junior, mid, and senior. Okay, and after that you have the lead, and again CEO. But in these days, so junior, we want to leave it for the people that have a bachelor in computer science. So you should aim at least at mid when you get out of a PhD or a master. Senior is for people who have at least PhD, but the people who get out from a postdoc, you can, like, you should try to get to lead as fast as possible. Like in my case, I had 1 year and a half as a senior researcher, senior data scientist, and then I switched to lead. So this is the idea. And this is connected with the next question, like how much time I have. I believe personally that 2-3 years before the people who actually started data science courses catch up and nullify the advantage that you have. So if you want to transition, I'm sorry, it must be happen real fast, because we are having, even here, we have the CSD combined with math. They started a data science course specific on that. So it's a master course. And imagine that in 2-3 years, this will start being shot out, like a lot of these people that have started studying those things 2-3 years ago. And there will be no practical reason for a company to hire an astrophysicist and convert it to a data scientist when you have the data scientist coming out straight with all the necessary tools that I mentioned and go directly into the job, okay? Because the soft skill stays, the extra ability to plan, to write proposal. These are very important. The independent, leading other people, supervising. This stays, but when you go through a job interview, they do ask, okay, what do you know? What can you practically do tomorrow? I will ask you to sit and start editing the code that is on Amazon Cloud. Can you do it? No, I need to study that part. Okay, very good. No, but I can learn it. Yes, I know. But there's this other guy which is not as smart as you, but can do it from tomorrow, and we will fire him in 1 year anyway. So who cares? You know what I mean? So I think that is also because, for example, things we were discussing, like even in this department, we need to have at some point some organization for the machine learning to go in that direction too, to have a connection, because otherwise you just cut out from the market. So think about it. Let me know in 2 years. And now I want to show you instead one example that we're working where also Tassos is really collaborating heavily, dealing with a lot of the machine learning part, which is this platform that we created in Streamlit, another tool that you can learn. which basically transports Python code, and you can actually visualize it in your web browser. So in this platform, we are trying to have an end-to-end processing of the data, where you have, as you can see here, you have several steps that they bring you educationally, from the data visualization to the pre-processing to modeling. And here we include neural networks, both purely classical and quantum neural network, quantum hybrid. Pipeline revision protocols like cross-validation, and then we have exploration of the results. For example, I zoom in because it's a bit out of focus. So we included, just for the sake of this presentation, the SDSS dataset, which is it's SDSS data release 7, where, as you can see here, let me move the columns. So we use this for the purpose of a classification problem. So we have objects that are galaxies or stars. In the dataset, there are also QSOs, but we drop them out for this example. And you have various properties, redshift, magnitudes. So for example, let's say that we want to classify galaxies and stars. So we select the StarGet.1, and we use a couple of magnitudes as our dataset. So now the dataset is restricted to U and G. If we want to add more magnitude, we can actually see the pair plot. If we add more, we go into PCA pair plot. So now these are the, no, up to 4, it's okay. I think it's 5, it's the PCA pair plot. Yeah, when you have too many dimensions, obviously you cannot have the coordinate plot of everything against everything. So we limit it and we do a PCA decomposition, where we can actually show every PCA against the other up to the 4th. So it's a bit more constrained. So we have also some, I will expect a bug to pop up anytime, so don't worry. We can add the pre-processing steps. For example, we want to add a standard scaler. Okay, we want to standardize the features, and this should visualize the thing before and after. I'm very proud of this plot. In this case, they're almost the same because they're already nicely distributed, so it just changes the scale. Let's see, I can add quantile transformation, and I try to get a uniform distribution out of it. Give it a second. Yeah. No, here I changed something in the matrix, and I removed the after. Okay. Then we can have the actual model, the actual modeling, where we have neural networks. So we have our inputs, okay? And we have set it up so that we can have quantum layers, or just classical layers. So this, I don't want to go into the description unless you're interested of how quantum computing works, but just trust that this is a quantum layer with, I have to set it to 5 qubits, otherwise it will crash, right? Must have the same size as the previous layer. Yes, I know. Yeah, well, forget it. I just delete it. I delete the layer. I don't want to bother. And I refresh. U G R. Okay, so I'll keep it simple just for this presentation, because quantum calculations takes more. So in this case, we just have input layer, a dense layer with 10 neurons. Actually, let's add one more to add some complexity. I will add another dense layer with another 10 units. we are working with Streamlit because it's a bit slow to refresh, but this is the idea. Okay, in this case, there is no classical equivalent because we remove the quantum layer. So once we are happy with this, here you can review the architecture, number of trainable parameters and whatnot, activation functions. We can switch to the pipeline and have set the number of data that we want for training, validation, and test. And when we're ready for that, well, here we envision also other things like cross-validation, but we don't have it ready yet. Then we can fit the model. So this will do the classical fitting, okay? So optimization of the neural network. What's happening?
There's a bug.
There is a bug, a lot of bugs, which is weird. Let me try again.
From scratch.
If it doesn't work, yeah, I played with this yesterday night and I was a bit tired. So it's very possible something. Okay, so I will reset it to the factory default. Okay, so now breast cancer is DSS. Is this SDSS thing that screwed it? Okay, I will keep it simple. I will just have two inputs and run it. Okay, so what you can see here is the evolution of the, well, I just set 10 epochs. Let me put a bit more epochs so you can actually see while it's running. 100 epochs. So here you have the evolution of your loss of your neural network as the epochs proceed. Then you have training validation. In this case, this one is now quantum because I reset it. So the actual model has a quantum, it's hybrid quantum. So it has input, one dense layer with 2 neurons, one quantum layer with 2 qubits, and then the output. And here we have the classical equivalent where we have number of neurons equal to the number of qubits, 2 to the power of number of qubits. And okay, so at the same time, at the bottom, we also have a representation of the network. So can I type here? I don't want this to become a class, but one of the problems of representing what's happening in the neural network, and that's why I'm actually proud that we did this, because it's actually very helpful, is so you have, for example, an input here, we have the 2 magnitudes, U and G, and this goes into, actually it's only 2 neurons, but let's say that we had 4. Okay, so we have this thing fully connected, and then another layer, and it's the same thing with all the connections and whatnot. So the problem is how this one, we have it at the beginning as a representation in 2D. And again, I'm saying all of this thing because this platform is exactly meant to be educational. So here you have G and U magnitudes, and this is easy to represent. If we go in more dimension, we said we use the principal, the PCA, the PC decomposition. Now the problem here is the same. We can represent this, okay? It's our magnitudes. When we get to the output, we can still represent it because it's 2 classes, so we can still put the data, fine. But here, how we can represent to see what's happening? Again, we can take the values of these neurons, do a PCA decomposition, and plot them in the principal component 1 and principal component 2. Mind you that this is a linear transformation. This is just a change of axis. But this is exactly what the network does. All of the network does until here, just before, is to create artificial features such that the 2 classes, they can be linearly separable. And look what happens, in fact. when you do it like this, so this is the output of the first layer, second layer, third layer, fourth layer, and so on. There are more because there are the activation functions that are considered layer. But here you can see what happens. You start from this scenario that we had at the beginning, where the labels, red and blue, they are mixed together, overlapping, and slowly, you try to separate them. Start to bring the blue one here and the red one here. Okay, so all of this network is basically a sequence of transformation that unfold your manifold into making it as flat as possible and be able to put a separation line there. If it's regression, of course, it's a smooth gradient, but in case of classification, it's sharp. So when you go into the result, now this network is not the best for this case. It must be more complex because it was underfitting. But anyways, this is just to give an idea of what you can visualize. So you have the rock curve. So you can even change the threshold of where you decide the probability of belonging to one class or another, because the system actually happens to be incorrect, spits out the probability to be of class 1. And this is a number between 0 and 1, could be anything like this. So you have to put a threshold. When do you say that the classification is 1 or class 0? Well, most intuitively, you set a threshold at 0.5. And if this is larger, you say, okay, this item is class 1, this item is class 1, and this item is class 0. So nobody tells you that this is the truth, because this is a probability, but the probability of the network is not the nature. And in fact, this is what we did with Babis, right? Remember probability calibration. So this is the probability calibration by hand. You can switch this probability and say, no, I believe that in reality, I should play with this. And so changing this, you get different metrics for the accuracies and whatnot. And then you can actually visualize also the decision surface. Forget this because this network didn't converge. Here you can see which is the probability to belong to class blue as a map. Okay, so this is actually the model applied in every single position of this plot. So you can actually nicely plot where something would be classified as red or blue. Okay, obviously, if we add training, if I was playing a little bit more with the parameters, this surface would get a bit more sophisticated. So this is the platform we are building. By the way, small but not small. We also have a chatbot, which Tassos built. So LLMs, the example of LLMs. So this thing is using the ChatGPT API in the background. So now we're creating. Tell me one example. What can I ask?
For the moment, it's only guiding you to the tab.
What
so I cannot see the results yet.
Seeing. Let's see. Send. Yeah. Which is QML Gladiator, because we're viewing the results, blah, 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 adjust the decision threshold for the classification task using a slider, review the performance, blah, 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 blah. Okay. So this helps with the, and you can keep chatting just like in GPT. So the idea is that you create this, you want to say how this is created, just as a brief.
How to build it.
How to build the prompt, blah, blah, blah.
Yeah, well, basically, okay. So the idea was to put the chatbot using the API of OpenAI to this platform. And basically what you need to do when you want to create a new LLM for you, you need to give some information about the environment or the data that you have, like a first prompt. And this is also called few shot learning, I think, when you give some examples, some info, so the chatbot knows what's happening. and then you can keep going with giving new prompts. Have you ever tried to create your own agent in ChatGPT?
Like
in the
you
Pro
can
version?
have this. You, I think you can, like, you have the extensions and you can create one of yours.
Yeah, and it's the same idea. There you can give the knowledge base of the chatbot, so it doesn't only rely on the training that it had or the internet. So you can give like a whole book that you have in a PDF or whatever. Here we give instruction based on what the platform
Displays.
displays or what it's used for. And then you can have like learn your own things.
So it's like you start a discussion with the bot by first of all telling everything that is available on this page, and then you say continue from there.
Yeah, this can be like
More or less.
10 pages of instructions, basically.
So I show this because I think that there is value that we can also coordinate and maybe have a proposal with the institute. Because I was thinking that one idea would be we can have something like this where we actually simplify all the data pre-processing that are boring stuff. By the way, why is this interesting? Because actually you can actually download the notebook, and this contains everything that you have pre-processed. Okay, so this exports this into a Python thing where we will also add the instructions based on the chatbot. So you will have actually a description. This block does this. This block does that. So far, you see here, is the code to load the data set. Hopefully it works. Who knows? I need to change the kernel. I think in this one should work. No, so I don't have the same. I don't have the packages installed, but if you install the packages, it runs. Yes. So it's all the thing that has been done. So pre-processing, for example, there is no pre-processing, obviously, because we didn't add. But for the model, these are the layers with two neurons, exactly as it was set up in the platform. So the thing is that we could do something like this for astronomy, where we can have, instead of having like we have classification, regression, time series forecasting, we have, for example, spectra pre-processing, spectra post-processing. For example, we can call for a prospector for detecting the lines or something like that. All this stuff that is kind of redundant. We can include things for Robopol, let's say, you know what I mean? Like all these things that we do, and maybe we have to start with a new project and do it by hand. And maybe with this, you can have a quick look of what's happening. You can do, I don't know, for the images, it could be, you do the bias, the flattening, you just pass the data and you say, do the thing, write me the code. You go through the several processes, you export the notebook, and then at the end, okay, if you wanted to play a little bit with the parameter because this image has to be discarded and whatnot, but then you can have all the visualization ready, okay? So you don't have to start typing the code every time or copy paste. You do something like clicking, you have the visualization ready, you say, okay, it's working, next, okay, export, and then later on you can take this chunk of code that is exported and put it in your loop or something like this. So this is something that you can, yes?
Yeah, we need to note that the notebook is not generated by AI. It is working. We have done it manually. So this is something that we need to note.
Manually meaning,
get...
in the sense that you have a template,
yeah,
and then the template is edited based on the builders that we have in our code.
Yeah.
Yes. Okay.
So
in that sense. Yeah, we cannot do this with AI because it's generative models, and so they have stochasticity, and you don't want stochasticity when you create code. So you do have to use the same assemblers, yes? Mm-hmm. But okay. So this is it. If you have any question,
I do.
Of course you do.
So, from your talk, as I understand it, if someone does not transition in the next 2 or 3 years, he's screwed. Can you go back to the slides that you ranked the different? Yeah, this one. If you have a PhD or even a postdoc, and you do not know how to work with any of this stuff or with many of this stuff, because okay, you might have used, you know the basic machine learning algorithms and techniques. You have worked a little bit with sklearn, with TensorFlow or whatnot. You know Python, but you know nothing of the rest. Then you are not marketable, right? If I understand correctly.
If the two things were identical, there would be no distinction between corporate and research, right? So there must be some difference, and the difference is in the actual pragmatical application of the things you know. Like you don't see Bayesian statistics here, for example.
Yeah, what I'm trying to say is that all this sounds a bit gloom, and I'm not sure if this is realistic, and you can tell me your opinion on that. I mean, how can it be that someone that has only a bachelor's in, okay, if you have it in computer science, then fine, although the market is very crowded, I'm sure. But if you have a bachelor's in mathematics, where you have done some coding on physics or everything in the natural sciences, how do these people get a job? And if they can't get a job, even at the junior level, I mean, you have to start from somewhere, then how is it that someone with a master's or a PhD or a postdoc cannot get a job?
Sorry, how they get a job essentially.
Yeah.
Which is the unemployment rate in Greece?
Sorry?
Which is the unemployment rate in Greece for people under 30?
Right now, I don't know for people under 30, but I would say it's something close to 9%.
9?
No.
40, you mean?
40? Below 30.
Yes.
So
40%?
Not 40, but probably because a lot of people work without declaring themselves, right?
Yeah.
I would say probably in the order of 25.
We're there.
so you get your answer. They don't.
I was not talking about Greece though, because all these positions that we're discussing here, you can do them. We are an international audience. People that are doing a PhD, are ready to travel abroad. So I don't think that we should be discussing Greece here.
Well, the fact is that most people that they don't have the other skills, they end up in this category.
Okay.
Mostly because it's the simplest to catch up. I mean, I guarantee you will find a job as a Python developer. It's a waste though, given
So
the
my
things
question
that
is,
you
how
learn.
does someone start? Let's say you don't want to become a developer.
Mhm.
You have a PhD, or you are doing a PhD, or you are at your postdoc.
Mhm.
Doesn't matter. But you don't have 95% of the things that you outlined there. How do you do the transition?
You select one of the area that interests you the most,
Yeah.
and then you study a little bit of at least one of those, because of course, if you learn cloud services, doesn't matter. I mean, once you know, and these have a lot of markets anyways. Or once you learn how to use one database, data frame, whatever.
And you can study on your own, or you said that Microsoft offers.
I'm sure about Amazon. I'm not sure about Azure, but I'm pretty much sure and confident it has. They have their own courses, yes.
So, Paolo, what did you do when you started your first job in industry? I mean, what skills did you have?
Well, actually,
Because that would answer
My
your question.
but actually I was lucky because I didn't look for a job. I was looked for. So I didn't have to present myself with this and that.
Why did they choose you?
This is a question that they have to ask. No, I assume that they wanted. No, I can tell. So the company, this company was young and needed people who could supervise other people. So this was part of the soft skill mostly, not the technical skills. It helped that I had some things on GitHub, so they actually could see that I could program without having to demonstrate it. But I think in that case, they needed someone who could supervise people, because one thing I noticed is that just because you have a lot of people that they start doing coding right out of the school, they don't have the expertise to carry out a project top to bottom. And maybe they go there and they execute the task you ask for, and then they say, okay, what do I do next? And they, stand. And so in that context, I was helping in this sense, because one thing is this sort of soft skill. Let's say this project I was doing, where I was using this technique, multi-objective Bayesian optimization, is not something that you can discuss with your boss. Like, the boss is like, okay, do this thing. How you do it, it doesn't matter to me. So you don't even, this is not even, like these things that you learn in astronomy, these analysis techniques, they're not even understood. You cannot spend one day to explain this thing. So what matters is, can you do this independently? They gave me 2 or 3 developers to help me setting up Kubernetes and AWS. And I didn't have to, know this thing, but they needed to know how to manage, how to invest their time, how, have this sort of soft skills, like supervision skills.
Okay, so when you started with this project, you knew nothing about these 4 things.
No, I knew about
softwares.
Docker, but not the others. For Kafka, I took a Udemy course.
Okay.
Okay, so do
Before or
these
after
things
your job?
Huh?
Before or after your job?
Immediately, like when I knew that the project was about it, I started studying Udemy course.
But after you got the job,
Yes, after.
it wasn't in preparation for the
No,
job.
no.
Okay.
In this case, no.
But of course, you would suggest that if someone is looking for a job during a PhD or a postdoc, it would be beneficial for them to study one of these frameworks, depending on what they want the job to be.
Yes.
Just so they have some experience, at least at the beginning level,
Yes.
at the classic level.
At least to have something that gives a little link to the corporate environment, not just to say, I know how to do this, how to solve this MCMC problem.
Also, but however, knowing how to do MCMC or being familiar with Bayesian statistics optimization in general, from what you say, I understand that it will be useful for you in solving the problems, but it's not as marketable directly.
Yeah, this is the thing. Yes, it's like
So it's
kind
not
of
that-
given for
It's not
granted
that you will get a job because you can do MCMC, but it will be useful
to solve
general,
there in
to be
practice.
able to
Yes,
know it.
you're like, that's what I mean when I was mentioning the PhD and postdoc. If you get as a PhD to the corporate, you're seen as a student. If you get out as postdoc, you're seen like a god. It's a big jump. You're like, oh, this guy knows how to do it. They give for granted, like this guy
But
will
you're
do.
professional.
Yes, and they trust every single word you tell them. Like, you don't know what I did here. Like, actually, it was only optimization of it. So, no, I'm saying these skills are, yes, are given for
Would
granted.
you propose that every piece of code that we write we put on GitHub?
Not every piece of code.
Everything that is readable and
Yeah, it must be readable. But I tell you honestly, you have to write a nice README file in the, like, for example, let me show you. No, this is the one we are working now, which is obviously secret, but here you will not see. So this is the organization of the project. So you have source, tests, demo, all the branches in the world, but the README file is very poor. We don't have much. Anyways, this is not public. Nobody will go and read your code. Nobody in the world. Like, I don't read his code. No, I'm kidding.
This code will be uploaded, right?
So, no, it doesn't matter. It's thousands and thousands of lines of code.
Of course, no one is going to read the code, but someone might see if you are, if you are functioning in that framework, if you have written any code.
Yeah, that's what I say. The good thing is to write a nice README that explains the things that you've done. Because this is the only thing, like, even me personally, when somebody applied, I went and didn't look at the code. I mean, there's no way I'm going to check the code. Because some people don't even write comments. But you read the README to see what this code does. And you understand if it's completely developed from that person, or it's just, oh, I took this and I tried to run it.
Okay, no,
So, it's much better to write a nice README file than having examples be, you know. That's my idea about GitHub.
So you work remotely? I see you here often, therefore
Yes.
you're around. So
Yes.
where is this company?
The company is based in Italy, but the R&D department is in Chania.
Ah,
So I'm second order remote, like
okay.
but I also teach the course here. That's why I'm squatting in the department. It's legal. Of the approval. Now, I don't want to scare you with this thing. Well, maybe a bit for the fun, but I didn't mean like, I'm trying to be realistic. Eventually, because the same punch in the face I received, I did also other applications. I admittedly was lucky with this, with my, you know, with the fact that it was companies approaching me. Because then after a while, you know, once you start working for a company, then you get also requests from other companies that want to steal you from there. So because it's like a sort of seal of guarantee, right? It's like, oh, this person was all the time in academia, now we take, and then maybe it's gonna take 6 months to adapt to the different working environments, learn whatever has to be learned. Instead, you have another person that already is in a company environment, already is maybe leading there. You know, it's like marriage, you know. When you're married, you have more requests.
I have a question about the platform that you presented. So I saw that you use neural nets, right?
Mhm.
But can someone use other algorithms, machine learning, for supervised tasks like random forest, SVM, whatever?
Yeah, we want to add. Should I show the benchmark?
Yeah.
Let's see if the benchmark works, because we have the other thing that runs the benchmark using the classical algorithms here, so that you have the baseline comparison essentially. So when you run the fit, after you run, 1 second. Now it's whatever is 1D. The task is very simple. 10 epochs. Yep. Okay, so here is the benchmark. I don't know if it runs. No, we have disabled it for the demo.
Yeah, one more.
I think if I insist,
Yeah.
come on. No, at the moment it's not available.
Okay, or
But-
for you to show this.
And then we stop here.
No.
Yeah, one last question.
Wait, actually, I have a question as an undergrad. You said that the most time you have to get out on the corporate is 2 to 3 years. But I need like 5 years minimum to get a postdoc.
Okay.
So what should I do? Like, should I try to do a master's on data science or just,
Life is unfair.
yeah, no.
What can I do is like, in 5 years, the science maybe is out of. No, there is no answer to this. In 5 years, maybe we will have chatbots that will replace scientists. Actually, I believe it's very possible. Low-level scientists like social sciences. And there is nothing to find. I mean, you have the advantage that you know where the things are going now and while you are doing the things. So take extra courses, take generative models. These are the things that the diffusion models, transformers, LLMs. Those are the ones that the companies require. Like if you try to go on LinkedIn, that's the suggestion. Try to go on LinkedIn and see people that do ML engineering, and you will see it's natural language processing, which means LLMs, and computer vision. I would say 70-30, but this is maybe unbiased because that's what I search. But this is the thing. So now that we have time, there is Pandasis, Yannis Pandasis from in which institute is he?
Mathematics.
Mathematics. He's doing a generative model course, for example. So this is one you can follow to catch up with these things. And then start playing around. Like there are a lot of pre-trained models. And, you know, the CV, can you stop the record a second?
Stop the record.